So we have the third and final question here. So two balls P and Q have masses 3 kilograms and 2 kilograms respectively. The balls are attached to the ends of a string. P is held at rest on a rough horizontal surface. The string passes over the pulley, which is fixed at the edge of the table. Q hangs vertically below the pulley at a height of 2 meters above the horizontal floor. And there's a nice little diagram. We've done that for us. So the system is initially at rest with the string taut. A horizontal magnitude of 40 newtons acts on P as shown is in the diagram. P is released and moves directly away from the pulley. A constant frictional force of magnitude 8 newtons opposes the motion of P. It is given that P does not leave the horizontal surface and that Q does not reach the pulley in the subsequent motion. The balls are modelled as particles, the pulley is modelled as being small and smooth, and the string is modelled as being light and extensible. So we need to put a few more things in this. So let's have a look. So there's two small balls P and Q have masses 3 kilograms and 2 kilograms. So we can put their weights in. So 3g there and 2g there. And then it says that the balls are attached to the ends of a string. So at this point you know there's going to be some tension, so let's put the tension in. And the tension always goes away from the particle. So tension goes away from the particle, and that's the tension acting on the particle, on the particles, not on the pulley. The pulley tension would be slightly different. Okay, so these are the tensions acting on the particles, and if you wanted to, you could put the pulley tensions in, and I'm going to draw it in green there and there. As always, it goes away from wherever it's acting on, so it goes away from the pulley. Right, now what else do we have? So it's held on a rough horizontal surface, so we know there's going to be friction. Okay, and I know because I've read this twice now, this is the second time I'm reading it, I know that friction we get told that friction later. Alright, so Q hangs vertically up below the pulley at a height of 2 meters, and they've already drawn that. The system is initially held at rest, so you might just want to write down U equals 0. A horizontal force of magnitude 40 newtons, that's already drawn on there. P is released and moves away, so if it's moving away, then we can draw our acceleration as going to the left, and for Q, that means the acceleration will go up. A constant frictional force of 8 newtons, so the frictional force, so we can put that in, and because P is moving to the left, the frictional force will be to the right. It is given that P does not leave the horizontal surface and Q does not reach the pulley in the subsequent motion. The balls are modelled as particles and the pulley is small and smooth and the string is light and extensible. Okay, fine. So let's have a look. Show that the magnitude of the acceleration of each particle is 2.48. Whenever you got this kind of question, usually the best thing to do is to look at each individual particle and look at the equation of motion for each individual particle. So P, so the force is acting on P. There's 40 newtons going to the left, 8 newtons going to the right, and tension also going to the right. So this is equal to mass, which is 3, times the acceleration. So that's the equation of motion for P, and generally that will give you 1 or 2 marks. And then if you look at the equation of motion for Q, Q is moving upwards, so therefore T is pulling it up, 2G is trying to pull it down, and there's no other forces acting on it, and so this is equal to 2A. Overall, these two combined will probably give you about 3 marks. And then you're told to solve for acceleration. So the other unknown in this is T, so we want to remove T, and the best way to do that is to add them together. So equation number 1, equation number 2, and I'm going to do equation number 1 plus equation number 2. And that's going to give me 32 minus 2g, and that's equal to 5a. And if we do 32 minus 2g on the calculator, 32 minus 2 times 9.8, that gives me 12.4 equals 5a, and then a is therefore equal to 12.4 divided by 5, and that is going to be 2.48. Exactly like we wanted, meters per second squared, and we've done what they wanted. Great. So that's 5 marks. So there's probably a method mark for adding them together and trying to solve the simultaneous equations, and then one final answer mark for getting the 2.48. So that's part A. Now let's look at part B. Find the tension in the string. So now that we found acceleration, we can take the acceleration and sub it into one of our other two equations. So we can sub A into, and I'm going to sub it into equation number 1, but it doesn't really matter. So it's got 32 minus t is equal to 3 times 2.48. And if we rearrange, 3 times 2.48 is 7.44, and so 32 minus 7.44 is equal to t. So t came out as 32 minus that is 24.56. And so that's 24.6 newtons. Okay. Or you could give it, and because there is g involved, and it depends on which way round you went, because g is involved, strictly speaking, we should give that as 25 newtons to 2 sig fig, because g is involved. Now I subbed it into 1, but I'm going to sub it into 2 and show you that it's possible. It gives you the same answer. So sub A into equation number 2. And if you subbed it into equation number 2, you've got t minus 2g is equal to 2 times 2.48. And so it's 19.6 plus 2 times 2.48. And it should give you the same answer. And lo and behold, it does. T is equal to 24.56. And as I said, here we definitely use G, so we should give our answer to 2 significant figures. So 25 newtons. And then their favorite question in part C. Let's have a look. When the balls have been in motion for 0.5 seconds, the string breaks. They love this kind of question. Okay, so the string breaks after 0.5 seconds. So we've been given some time. So t equals 0.5. Remember that we wrote down u as well earlier because they told us it was at rest. And then we've also worked out a. So this looks like a SUVAC question to me. So let's see what are they asking. Find the additional time that elapses until Q hits the floor. So if you try and think about what actually happens to Q, P drags Q upwards. Half a second later, the string snaps. And so Q is going upwards with an acceleration of 2.48, and then suddenly the string snaps. The string that's pulling it up snaps. And so it'll do a little, basically, it's like you're throwing the particle up. And so it'll go up for a little bit, and then it'll come back down, and it'll hit the floor. Okay? But in those two motions, so the first 0.5 seconds is being pulled up by a piece of string. And so its acceleration is upwards 2.48. Let's work out the final velocity and the distance it travels in this time. Okay, so the final velocity, we can do various equations. I'm going to use v equals u plus at. I like v equals u plus at. It's nice and simple. So v is equal to u plus at. And we'll get rid of s for a second, and I'll work it out in a second. So u is 0 plus at. So that gives me half of that, which is 1.24. So we know that the final velocity, when the string breaks, Q is traveling upwards at 1.24 meters per second. But how far has it traveled? Why is it important to know how far it's traveled? Well, it's important because basically this is Q's life. Q would have started over here. It would have gone up for half a second. Then this is when the string breaks. It would have done a little bit more and then come back down. And that's the end of journey for Q. So in that first half a second, in this bit here, we want to know how far it's traveled, okay? Because we want to then work out how high up is it, so that we know, then we can calculate the second bit, how long it takes to travel downwards. Okay, so S. Which equation? You've got 4 choices here. Whichever one you want to choose. I'm going to use s equals ut plus half at squared. I choose to avoid v, using v, because just in case I've made an error calculating v, I've got the u and the t and a from before. So s equals ut plus a half at squared. And this comes out as, let me do that on my calculator, half times 2.48 times 0.5 squared. Fantastic, and that gives me 0.31. So now I know it's traveled 0.31 meters above. So it's traveled 0.31 meters up from where it started. It started 2 meters above the ground, so now it's actually at a height of 0.31 meters per second. I'm going to do the second phase. So this is a multi-phase problem, and in the second phase we know that the particle has to travel downwards by 2.31 meters per second. 2.31 meters. Do we know its initial velocity? Yes, we know that the initial velocity for the particle is going to be the final velocity from the previous phase. It's going to be traveling upwards at a velocity of 1.24 meters per second. Do we know its final velocity when it hits the ground? No, we don't. That looks like a y, right? And then a, well, what's its acceleration going to be? It's the only forces acting on this particle now, because the string's broken, the only forces acting on the particle are gravity. And gravity is going to be pulling the particle downwards with an acceleration of 9.8. I'm giving it an acceleration of 9.8. And then time, we don't know. Okay? So, and that's we want the additional time. I just want to check. We want the additional time. Okay? Just go back. It says the additional time that elapses. So we want the time in this second phase. So we can do, we want to find time. We don't want to know anything about v. The equation that doesn't have v in it is s equals ut plus half at squared. So s is minus 2.31, and that's equal to 1.24t minus 4.9t squared. So this is a quadratic 4.9t squared minus 1.24t minus 2.31, and that's equal to 0. And let's put all that into our quadratic formula. It doesn't look like it's going to solve, so we're going to use the quadratic formula here, or we can use our calculators to solve this. And when I do, it gives me t as equal to 0.8246 something, and then the other answer is minus 0.571. But it can't be this answer anyway because it's negative. So the time that elapses, the additional time that elapses, is 0.83 seconds. 0.82 seconds. I'll just check. Did it ask for any specific? It didn't say to any number of significant figures, but I used G, so I would give my answer to 2 significant figures here, because we've used G. The other thing that they sometimes ask is, find the total time or things like that. So just look out. This one said additional time, so the answer is 0.82 seconds. Okay, thanks for listening in. That's the whole of the Mech test.